Okay, this is for lesson 14 in module 4. And today we are going to be constructing triangles from given criteria. And so what we're going to be doing is making triangles that have to fit the certain information that we're looking for. So before we actually get to that part, we're going to do a little review. And hopefully you'll find this review interesting because what we're going to do is we're going to play with some food first. And so we are going to go ahead and review our triangles from yesterday. And we made an equilateral, and we talked about what an equilateral triangle is, and that is one that has equal sides on all three sides. And so I have some veggie straws here, and they are all the same length. So all I have to do is put them together to make my equilateral triangle. There we go. So there's my equilateral triangle. Next, we make the isosceles triangle. What we're going to do, if you remember, an isosceles triangle has two lengths of the same length, two sides of the same length, I should say. So this is where the fun part comes in. You notice that all three of these are the same length. Well, I'm actually, and I do have one that's a different color, and I think that if I keep these two the same, well, I know they're the same length, this one I need to shorten up a little bit. I can't lengthen it, that would be crazy, but I can always shorten it. So I'm just going to go ahead and shorten it a little bit. Just take a bite right out of it. So now it's a little bit shorter. So that's where the fun part comes in. So I am going to go ahead and connect those, and you see that these two sides are the same length and this one is shorter. And the third one that we're going to do is the scalene triangle. And a scalene triangle, if you remember, has no sides of equal length. So for my third one, I'm going to go ahead. I have another 3 veggie straws here. Right now, it looks like 2 are the same length and one's a little bit longer. So I'm going to keep the long one, but I'm going to make one of these, since those two would be different. I'm going to make this one shorter than the other one. So by just taking a little bite out of it. So now I have 3 of the sides, and they're all different lengths, so I can put them together down here. There we go, so you can see. I'll just do it right over here. So I have a short side, a long side, and kind of a medium side. And if I wanted to, I could go ahead and mark these. And we would say that these are equal, so I'm going to put the same mark on each one of them. Sorry about the shadow there. That's better. You can see it. These two are the same, but this one's different, so I'm going to mark it with 2 hash marks. And for the third one, I'll just put it right up here so I don't have to keep moving it. 1. This one would be different. I'm going to put 2 marks, and for this third one, I'll put 3 marks. So now I can tell just by simply looking at the marks what triangle I have. Equilateral, all 3 sides are the same length. Isosceles, 2 sides are the same length. And scalene, all 3 sides are different. There are no sides that are equal. And if I flip this over, we could make the other 3, which is an acute triangle. And I know that if I just use those same three right there, I can tell that, of course, I would use my right triangle template here. And yeah, they are all acute angles. So all three angles have to be acute for that one. All right, the next we have our right, which we need a right angle. And I'm just going to use the same ones here. And if I put my right angle template in here, you can see that they would be matched up. Move that down so we can see it. There we go. And I just have to connect them here. So maybe I should have chosen the longer one for, I don't know. You get the idea here. I want a right angle right there. Okay. And last, we have an obtuse angle. And so I'll use my last three here. And for this one, we know we want, whoops, I'm messing up this one. Try to keep that as best I can there. All right, we know an obtuse angle is greater than 90 degrees. So if this is 90, I'm gonna open that up a little bit. So now we have our obtuse angle right there, which if I were to put that, I can see that it does open up greater. So anyway, that is just a review, and we could always use, if you don't have veggie straws around, pretzel rods are a great idea too. Also, packs of spaghetti. Now I happen to have some fettuccine noodles here, and I could use them. And so if I were in a two, I know these two are the same length, and if I measure that and break it right here, there we go. So think about what triangle is that there? I've got two equal sides and one that's different. So again, using food, it's a great idea. So now I'm going to set those aside, and we are going to get to what we're actually doing today. And that is to construct a triangle that has the given criteria. And so our first one that we're going to work on is an obtuse isosceles triangle. So obtuse, from our review just now, we know that it has an obtuse angle. Isosceles, we know that it has to have two equal sides. So I'm going to use my straight edge, and I'm also going to use my right angle template here because I need to know if it's obtuse or not. So I'm going to first just start off by drawing a line segment. And you don't have to have a ruler. You can actually measure without a ruler to make sure that you have the same size. So I'm just going to take this other sheet of paper here, and if I place the corner of this paper where this vertex will eventually be, and so it's lined up here, and I come over here and I make a mark where it ends. So from this corner to that mark, I know is the same length as that line segment. So I could actually, let's go this way. Now I don't want it to go straight up and down because that would be a right angle, and I want it to be obtuse. So I'm going to open this up some. And if you remember, I went from this mark to the corner. I could draw along that paper and stop right here. So I know that this line segment is the same length as that line segment. And so now I just need to connect the two other points. And so if I line my straight edge up carefully here, and connect those 2 points. I know that this is an obtuse angle, and I know that these 2 sides are the ones that are the same length, and this one is different. So I have constructed an obtuse isosceles triangle. It's obtuse because it has the obtuse angle in it. It's isosceles because these 2 sides are the same length. So that would be our first one. Now we come to our next one, a right scalene triangle. We know a right angle, so we can just simply start by using our right angle template here and just tracing that corner. So I know that this is going to be a right angle. So there's my right angle. But now we have to work on the scalene part. And the scalene, if you remember, is 3 sides that are different lengths. So I'm going to just go ahead and I'm going to use this length that I've already measured here. If I were to place that right in the vertex here and bring it over to the end. There we go. So I know that that side is that long. It's the same length as these 2 sides up here. Not that that really matters. This other side I know has to be shorter than that or longer. So based on that, I'm going to make it shorter. So if I line that up, I know this would be the same length, but I want to make it shorter. So I'm going to come about right in here and draw that up to the vertex. There we go. And you know what I will do is I'm going to mark that on my paper. Just a little tick mark there so that I know where it is. So I have this side is a certain length, this one is a certain length. And the question is when I connect these 2 points, hopefully it's not the same length as those. And I can easily check that by seeing if I line up the vertex of, or the corner of the paper with this vertex, here's one mark, here's a second mark, and here's actually the other vertex. So I know that this line, this side of the triangle, will be a different length. So I'm just going to use my straight edge and go ahead and connect those. So I know that this one is a 3rd length. So do I have the right part of it? The right angle? Yes, I do. I have a right angle. I measure that at first. Is it scalene? And I can say yes, it is. So I can actually check off the criteria that it's asking for. And I could have done the same thing up here. Is it obtuse? Yes. I can check that off. It is obtuse. I made sure that this angle is obtuse. Is it isosceles? Yes, I made sure that both of these sides are the same length. So now what I thought we would do is I kind of just made those up, but actually I have a bucket here and it has all of the names in here. So what I thought I would do is just simply, I'm going to make sure I draw one by sides, equilateral, okay? And one has to be by, I should show you what I'm doing here. So one by angle. So isosceles is a side, so I need one by angle, and we'll pick this one here. And I have them in 2 different, so we have equilateral and acute. Can I make an equilateral acute triangle? This one's a tough one. All right, so first thing I'm going to do is I'm going to start, I know it has to be 3 angles or 3 sides of the same length, and they have to be acute. So I'm going to start by simply drawing a line, and I'm going to make a mark right here. I'll make a mark so you can see it better here. Right there. So I went from the vertex to that mark. So I know that all 3 have to be that length. And if I came here, if I made a mark right about there. That would be from this vertex to here. Again, it's the same mark I made, so I know it's the same length. But here's the tricky part. Is it the same length going this way? And I can automatically see that it is not. I have opened it up too much. So I'm going to put that mark right here, and I'm going to see if I can get this right. I need to come somewhere in this area right here. Of course, I think I chose the hardest one, or we drew out the hardest one. If I went there and right there, I think I got it. All right, so are they equilateral? Yes, because I used the same distance on my right angle template to make all the sides. Are they acute? Well, I can see by using the right angle template they are hidden or behind the 90 degrees that the right angle template shows. So that's an acute angle, that's an acute angle, and that's an acute angle. So that would make it an acute triangle because it has 3 acute angles. So that is what this lesson is all about. Can I create a triangle using the given criteria? Since I've used those, let's try one more. I'm going to go ahead and draw from my bucket here. This time I drew the angle first, and then let's see, a right isosceles. And it really doesn't matter whether the angle comes first or the sides come first. That really, it doesn't change things. So since we are drawing a right isosceles, I'm going to use my right angle template, and I'm going to use that same mark, and I'm going to go ahead and draw my first line segment from the vertex of my right angle template to that mark. And now what's going to be really easy is, because I'm drawing a right angle, if I line that up with my right angle template, I can use that same mark over here on this side, which I haven't drawn yet. And I know that it's lined up, so it's going to be a right angle. And because I'm using the same distance, I know it's isosceles. So I know this and this are the same distance, so it makes it isosceles. I measured using my right angle template that is a right angle, and so, but it doesn't make it a triangle right now. Why is that not a triangle? I've got the right angle and I have isosceles, but it's not a triangle. What's missing? Well, the third side is missing, because all triangles have 3 sides and I've only got 2 sides, so I just have to connect the dots here to make my third side. So I have a right isosceles triangle. All right, so here's a bonus piece of bonus information for you. All triangles contain 180 degrees. If you were to measure all 3 angles, they would add up to 180 degrees. Now think about this. This, we said an equilateral triangle is equal sides, but not only that, it's equiangular, which means all the angles are equal as well. So that's a little bit of bonus information. If all 3 angles are the same and all triangles have 180 degrees, think about what would each of these measure, and would they be in acute triangles or acute angles? So just a little bonus piece of information for you. All right, that does it for this lesson, and you're going to go work in your Learn book, and there are some criteria given right here on page 109. They want you to draw a right isosceles, kind of like this one that we just did, obtuse and scalene, acute and scalene, acute and isosceles. So there are some criteria there that they're given. And then these questions, are they true or false? So think about the definitions, and hopefully you have your study guide from yesterday that if we measured triangles by sides, equilateral, isosceles, or scalene, we have that information, and by angles as well, acute, right, or obtuse. So this study guide would be very important. And for your exit ticket tomorrow or today, these two, numbers 1 and number 2, you're going to be drawing a picture and either posting that picture to Canvas and submitting that. And then number 3, every triangle has at least blank acute angles. That one is also on the exit ticket as well. So I want you to think about how many acute angles does every triangle have. So, all right, hope you have a great time constructing triangles. Hopefully you have your tools available to you, or you could always use some food as well. So, all right, have a great day.